coefficient method of solving simultaneous equations. Let us first see what is meant by a determinant. Let A, B, C and D be any four numbers. If the numbers are represented as shown here, then it is called the determinant. The value of this determinant is AD minus BC. How many rows and columns are there in this determinant? In this determinant, the numbers A and B are in the first row and C and D are in the second row. If we see column-wise, A and C are in the first column and B and D are in the second column. So, there are 2 rows and 2 columns. Hence, this determinant is known as a second order determinant or a determinant of order 2. Although there exist determinants of higher order, we are going to study only determinant of order 2 by 2. We will now learn how to find the value of the given determinants. How do you find the value of the determinant 5, 2, 7, 4? The value of the determinant is 5 into 4 minus 2 into 7, which is equal to 6. What is the value of this determinant? The value of this determinant is 3 root 6 multiplied by 2 minus 4 root 2 multiplied by 5 root 3, and this is equal to 26 root 6. The value of the third determinant is minus 4 upon 7 multiplied by minus 2 upon 5 minus 6 upon 35 multiplied by 5, and this is equal to 38 upon 35. Let us now see how to obtain the solution of simultaneous equations by using determinants. Let a1x plus b1y equal to c1 and a2x plus b2y equal to c2 be the given simultaneous equations where x and y are variables and a1, a2, b1, b2, c1 and c2 are constants, such that a1 b2 minus a2 b1 is not equal to 0. Let us solve these equations. Solving by equating the coefficient method, we get x is c1 b2 minus c2 b1 upon a1 b2 minus a2 b1. Similarly, we get y is a1 c2 minus a2 c1 upon a1 b2 minus a2 b1. We will now write this value of x and y in the form of determinants. We know that the value AD minus BC can be represented in the form of determinant as shown. How do we show C1 B2 minus C2 B1 in the form of a determinant? The determinant form of C1 B2 minus C2 B1 is as shown here. In the same way, determinant form of A1 B2 minus A2 B1 can be written as shown here. Therefore, the value of x can also be written in the determinant form. X is C1 B2 minus C2 B1 upon A1 B2 minus A2 B1, which is determinant of C1 B1 C2 B2 upon determinant of A1 B1 A2 B2. Let us denote determinant of A1 B1 A2 B2 as D and determinant of C1 B1 C2 B2 as dx. Therefore, x is dx upon d. We will now write y in the determinant form. Y is a1c2 minus a2c1 upon a1b2 minus a2b1, which is determinant of a1c1 a2c2 upon determinant of a1b1 a2b2. Let us denote determinant of a1c1 a2c2 as dy. We know determinant of a1b1 a2b2 is d. Therefore, y is dy upon d. Thus, we have got x is dx upon d and y is dy upon d. This method of obtaining solution of simultaneous equations by using determinants is called as Cramer's rule, as it is named after the Swiss mathematician Gabriel Cramer. He showed excellence in mathematics from an early age. At the age of 18, he received his doctorate, and at 20, he was co-chair of mathematics. He was professor at Geneva and has lot of mathematical achievements under him.
We will put Cramer's method of solving simultaneous equations in a nutshell. 1. To write the determinants d, dx and dy, remember the sequential order of the columns. A1, A2, B1, B2, C1, C2. 2. While writing d, omit the column C1, C2. So, d is equal to A1, B1, A2, B2. 3. For writing dx, omit the column of the coefficients of x in d, that is A1, A2, and take the column of the constants, that is C1, C2 in its place. 4. For dy, omit the column of coefficients of y in d, that is B1, B2, and take the column of constants, that is C1, C2 in its place. Observe and remember this flowchart, which shows the method of solving simultaneous equations by using Cramer's rule.
Let us now solve a few simultaneous equations using Cramer's rule. In question 1, we have to solve the equations 4x plus 3y minus 4 equal to 0 and 6x is 8 minus 5y. First, we will write the equations in the general form. That is, 4x plus 3y equal to 4 and 6x plus 5y equal to 8. On comparing with the standard form, a1x plus b1y equal to c1 and a2x plus b2y equal to c2, we get a1 is 4, b1 is 3, c1 is 4, and a2 is 6, b2 is 5, and c2 is 8. We know that d is determinant of a1, b1, a2, b2. On substituting the values of a1, a2, b1 and b2, we get d is determinant of 4, 3, 6, 5, which is 4 into 5 minus 6 into 3, which is 2. Now, dx is determinant of c1, b1, c2, b2. On substituting the values of c1, c2, b1 and b2, we get dx is determinant of 4, 3, 8, 5, which is 4 into 5 minus 8 into 3, which is minus 4. We know that dy is determinant of a1, c1, a2, c2. On substituting the values, we get dy is determinant of 4, 4, 6, 8, which is 8. Applying Kramer's rule, we get x is dx upon d, which is minus 4 upon 2, which is minus 2. And y is dy upon d, which is 8 upon 2, which is 4. Therefore, x is minus 2 and y is 4 is the solution of the given equation. Let us solve one more question. Here the equations are y is 5x minus 10 upon 2 and 4x plus 5 is minus y. On writing the given equations in the general form, we get 5x minus 2y is 10 and 4x plus y is minus 5. Comparing these two equations with the standard form a1x plus b1y equal to c1 and a2x plus b2y equal to c2, we get a1 is 5, b1 is minus 2, c1 is 10 and a2 is 4, b2 is 1, c2 is minus 5. We know that d is determinant of a1, b1, a2, b2. On substituting the values of a1, b1, a2 and b2, we get d is determinant of 5 minus 2, 4, 1, which is 13. We also know that dx is determinant of c1, b1, c2, b2. On substituting the values of c1, b1, c2 and b2, we get dx is determinant of 10 minus 2 minus 5, 1, which is 0. Now, dy is determinant of a1, c1, a2, c2, which is determinant of 5, 10, 4, minus 5, which is minus 65. Applying Kramer's rule, x is dx upon d, which is 0 upon 13, which is 0. Y is dy upon d, which is minus 65 upon 13, which is minus 5. Therefore, x is 0 and y is minus 5 is the solution of the given equation.
Let's do an activity. Here, we have to fill in the empty boxes to solve the given simultaneous equations by determinant method. The equations are y plus 2x minus 19 is equal to 0 and 2x minus 3y plus 3 is equal to 0. Solution. Let us write the given equations in the form ax plus by is equal to c. So the first equation is 2x plus y is equal to 19 and the second equation can be written as 2x minus 3y is equal to minus 3. Now, d is equal to dash, dash, 2, minus 3. Here, the boxes in the first row are empty. What numbers should we write here? Yes, d is equal to a1, a2, b1, b2. The numbers in the first row should be of the values of A1 and B1. Here, A1 is equal to 2 and B1 is equal to 1. Therefore, write 2 in this box and 1 in this box. Now let's go to the next empty box. D is equal to A1B2 minus A2B1. So here, D is equal to 2 into minus 3 minus 2 into 1 is equal to minus 6 minus 2, which is equal to minus 6 minus 2, that is equal to minus 8. Now we will fill the remaining boxes. Dx is equal to 19 minus 3. 1 minus 3 is equal to 19 into minus 3 minus 1 into minus 3. That is equal to minus 57 minus 3 is equal to minus 54. dy is equal to 2. 19 minus 3 is equal to 2 into minus 3 minus 2 into 19. That is equal to minus 6 minus 38, which is equal to minus 44. X is equal to dx upon d. Therefore, x is equal to minus 54 upon minus 8, which is equal to 27 upon 4. Y is equal to dy upon d. Therefore, y is equal to minus 44 upon minus 8, which is equal to 11 upon 2. Therefore, x, y is equal to 27 upon 4, 11 upon 2 is the solution of given simultaneous equations. Here's another activity for you. Complete the given activity. Here also you have to fill in the empty boxes and find the solution of the equations 3x minus 2y is equal to 3 and 2x plus y is equal to 16. Are you ready for the activity? Yes. Complete it then. Let me check what you have done. You got d is equal to 7, dx is equal to 35, and dy is equal to 42. Using Cramer's method, you obtained x is equal to 35 upon 7, which is equal to 5, and y is equal to 42 upon 7, which is equal to 6. Therefore, x, y is equal to 5, 6 is the solution of the given equations. Very well done. Now just think over and try to answer these two questions. 1. If d is equal to 0, then what will be the nature of the solution? 2. If there is no common solution, then what will be the nature of the lines representing the given equations? If the value of d is 0, then there will be infinitely many solutions, since a1 upon a2 will be equal to b1 upon b2. For example, x plus y is equal to 2 and 3x plus 3y is equal to 6. For these two equations, a1 is equal to 1, b1 is equal to 1, and C1 is equal to 2, and A2 is equal to 3, B2 is equal to 3, and C2 is equal to 6. Let's find the ratio A1 upon A2, B1 upon B2, and C1 upon C2. A1 upon A2 is equal to 1 upon 3. B1 upon B2 is equal to 1 upon 3. And C1 upon C2 is equal to 2 upon 6, which is equal to 1 upon 3. Therefore, determinant of A1, B1, A2, B2 is equal to A1, B2 minus B1, A2, that is equal to 0. If we draw the graph of these two equations, we get coinciding lines. That means these two equations have infinitely many solutions. When there is no common solution, that is, when the lines representing the given equations do not intersect each other, then the lines will be parallel to each other as shown here.